In this video, let's review triangle proofs and CPCTC. So, what is CPCTC? It stands for corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. Use when asked to prove parts are congruent. But first, you must prove the triangles are congruent. Let's look at an example with CPCTC. So we're given that side AB is congruent to AD. So I'm going to go ahead and mark AB is congruent to AD. That's a given statement. Side AB is congruent to AD. And the reason is that it's given. Number 2, we're given that side BC is congruent to CD. So let's mark that on our triangle. BC, I'll use 2 little marks, is congruent to CD. Alright, so BC congruent to CD, and that statement is also given to us. We want to prove that triangle BCA is congruent to triangle DCA. So BCA is congruent to DCA. Well, there's a third side that's congruent to itself. You can see that we have a shared side for both of these triangles. So we can say that AC is congruent to AC. This is called the reflexive property. When something is congruent to itself, it's the reflexive property. Alright, so now what do we see? We've got 3 sides of one triangle congruent to 3 sides of another triangle. So we can say that triangle ABC is congruent to triangle ADC, and this is by side, side, side. If we can prove that these 2 triangles are congruent to each other, then we can say that angle BCA, and let me highlight that, BCA is going to be congruent to angle DCA. So angle BCA is congruent to angle DCA, and that is by corresponding parts of congruent triangles being congruent. Let's take a look at another example. Alright, so we'll start with our given statements. Side PS is going to be parallel to side QR. So PS is parallel to QR, and that is given. Our next statement says that QPS, so this is angle Q to P to S, is congruent to angle SRQ, S to R to Q. Alright, so I'll make that mark. Q to P to S is SRQ. Let's write that down. And that is a given statement. We have a shared side for both of these triangles, so we can say that QS is congruent to QS by the reflexive property. And let's see. If we know that we've got some parallel sides and a transversal, then we also know some alternate interior angles are congruent. And so we can say that PSQ is congruent to angle, let's see, PSQ RQS, and that is that alternate interior angles are congruent. Parallel lines cut by a transversal have alternate interior angles congruent. Okay, so now let's see. We have on each of these triangles an angle, and a side. The side is not included, so it's an angle, angle, side. We can say that triangle PSQ is congruent to triangle RQS, and that is by side-side angle. Just kidding. Angle, angle, side. As soon as I wrote that, I knew it was the wrong thing, because remember, this is not, whoops, that one's okay. This is not a triangle congruence theorem. All right, so angle, angle, side proves these two triangles are congruent. So now PQ is congruent to RS, and that is by corresponding parts of congruent triangles being congruent. Okay, it just takes practice. Let's look at another example. X is the midpoint, this is the middle, exactly the middle of WY. That means each of these segments is congruent to each other if you're cutting exactly in the midpoint. So this is given. X is the midpoint of WY. Oops, I should have read a little bit further. And VZ. So VZ is also bisected by X, and these are given. Well, if WX is congruent to XY, that's because of the definition of a midpoint. Midpoints are exactly in the middle of a segment, and so they have two congruent parts. We can say the same thing for VX being congruent to XZ, definition of a midpoint. All right, we also have vertical angles here. Right here at angle X, we've got WXV and YXZ. So let's write that down. Angle WXV congruent to angle YXZ, and this is vertical angles. Definition of vertical angles. And now we can see that we have a side with an angle and another side. The angle's in between, so by side angle side, we can prove that triangle WXV is congruent to triangle YXZ. And if the triangles are congruent, then we can say that angle XWV is congruent to angle XYZ by corresponding parts of congruent triangles being congruent. Have you noticed a theme? Seems like all of our answers end with this. All right, last example. Start with our given statements. JM bisects angle KJL. Let's take a look. JM bisects KJL. So I've got congruent angles. This is given. And we also know that angle JMK is congruent to angle JML. So JMK, this obtuse angle, is congruent to JML, this obtuse angle. All right, so let's go back to statement 1. if JM bisects KJL, then we know that angle KJM is going to be congruent to angle LJM. And this is the definition of an angle bisector. All right, we have a shared side, so we can say that JM is congruent to JM by the reflexive property. Let me make a mark on that. And so what we've got is an angle, a side, and an angle of this top triangle congruent to an angle, side, and an angle of this bottom triangle. And so triangle KJM is congruent to triangle LJM by angle, side, angle. And if that's the case, we can say all the parts, including JK, congruent to all the parts of the other triangle, including JL, by corresponding parts of congruent triangles being congruent.